Okay, we're going to continue on with this Module 3 lecture note. Um, Yesterday we ended in 3.3. If you have questions about that, please send them to me and I will answer them, or we can answer them in class on Tuesday. So, continuing on, we are going to do applications of adding and subtracting. In Module 3.2 and 3.3, we practiced adding and subtracting. Now we're going to do basically a bunch of word problems to be able to use that math to solve real world problems. Okay, so we have this group of questions here as our start. Given 15 equals -4 plus something, what is the something? Um, it asks us the question, sorry, would the missing number need to be positive or negative? So if we're going to end up with 15 and we're going to start at -4, how do we get from -4 up to 15? Do we add a negative or a positive? We can use any of the models that we've looked at before, like a number line, for instance. If I go from -4 and I add something to get to 15, this is going to be a positive. It'll take me 4 units to get up to 0 and 15 more to get up to 15. So in total, that number in the blank is a 19. You can do the same thing with all of them. You don't have to necessarily draw a model like I did, but you do need to answer the question, would the missing number be positive or negative? I have some number. I'm going to subtract 47, and I'm going to end up at -82. So I have some number that I don't know. I'm going to subtract 47 from it. I'm going to end up at -82. 0 is 82 units away. I only moved 47 units to get where I was going. So this number here has to be negative. If I add 47 to both sides of the equation, I get the unknown number equals -82 plus 47. And that'll get me another number. Let's see. To subtract, I take the bigger number on top, smaller number on bottom. I can't take 7 from 2, so I have to borrow. 12 minus 7 is 5. 7 minus 4 is 3. Because my bigger number is negative, my answer is -35. That is my unknown number. Okay. I'll let you work on the next two yourself. Let's go to the next section. And again, if you get stuck on any of these questions, bring them up in class. We'll go over them on Tuesday. Okay. Apply properties of operations to add and subtract numbers. We have this big string of numbers to add and subtract. Let's simplify things by, for instance, we're subtracting a negative here. That's the same as adding a positive. We are adding a negative. We can simplify that to be just subtraction. So what we started with is the same as what we just wrote, which simplified some of the subtraction and addition. Now, you can just start on the left and move to the right, and that would work just fine. Or you can find convenient numbers to group together, and that works too. If I just go left to right, -15 minus 3 is -18. And I see a -18 and a +18. I can cancel that. I can if I want to. The -18 cancels with the +18 to give me 2 minus 7, which ends up being -5. If I don't notice that, I can continue on as I was going. -18 plus 2 is -16. Negative 16 minus 7 is negative 23. Then I have different signs. I have a negative 23 and a positive 18. Since they are different signs, I use my subtraction algorithm. I need to put the big number on top. That's the 23. I subtract the 18. I can't take 8 from 3, so I borrow. 13 minus 8 is 5. 1 minus 1 is 0. The bigger number was negative. That means that my final answer is negative 5, which is what I got from my earlier method. So this properties of operations that it's talking about, that's the associativity and the commutativity of addition that we talked about in class. The ability to rearrange the order when you're adding and subtracting without changing the value that you end up with at the end. So if you notice, it was a lot faster to see some appropriate grouping and not have to do this part of my problem. It is nice to find faster ways to do problems, although whatever way you think of is the best. You shouldn't worry about finding the best way to do a problem. You should think about how can I solve the problem, and then after you've done the problem and you have a solution and you're good, you can go back and see, were there any things that I did during this problem that I could have done better, so that the next time I need to do a problem, I'm faster and more accurate. Okay, let's look at this problem here. I see adding a negative, and I see subtracting a negative and adding a negative. That means this can be written as negative 10 minus 6 plus 2 minus 5. From here, I don't see any particularly clever way of shortening the problem from here. We can just go negative 10 minus 6 is negative 16. They have the same sign, so we add those values together. Then we have different signs, negative 5 and positive 2. 5 minus 2 is 3. Oops. The bigger number was negative, so my answer will be negative. So this positive 2 and negative 5 turns into a negative 3. And I combine those together to give negative 19. I will allow you to do the rest of those problems. It says, note, the commutative and associative properties that applied in addition do not apply in subtraction. Switching the order in subtraction, see how we switched the 5 and the 3, and one of them is positive 2, the other one is negative 2? So we can swap the order of subtraction problems. 18 minus 21. We should write it as 21 minus 18 when we do our algorithm, but that switches the order. And switching the order is going to switch the sign. So we take care of that by just knowing that since we switch the order, we're going to get the opposite sign. I subtract this, I get 3. So the answer to 18 minus 21 is negative 3. Just like how switching the order of the numbers switches the sign on the answers. That happens for any subtraction problem. Okay, let's keep going. We talked about Polya's problem-solving strategy. No, we didn't. We went through the first day without talking about Polya's problem-solving strategies. We'll need to talk about that now. So, before we get into any of these problems, there are 4 principles that Polya, a famous mathematician from about 100 years ago, that he gave for how to break down problems. The 4 principles are understanding, planning, doing and reflection. Reflecting. Okay. Understanding is we have to know what our goal is, and then we have to figure out what is useful to that and what is not. When we look at a problem like this, we should say, no, reading is great. You should love reading. I love reading. Reading is great. But when we're in a test, we should go into the test thinking, what am I reading for in the test? What is my goal, and how do I get to that goal? The way to figure out what your goal is you want to look for two things. Are there questions, because you have to answer the questions, or are there commands? Okay, so by commands, I don't see any on this page right now, but for instance, in this statement here, it says apply properties of operations to add and subtract. They are commanding you, they are giving you the direction, the instruction, please add and subtract using your operations, okay? So your goal is to do that. Anything it tells you to do and any questions it asks, you need to answer the questions and do the thing in order to get all of the points for your test, okay? So we have a question here. What is the new altitude of the airplane? Altitude means how high the airplane is. So I'm thinking of trying to figure out how high is the airplane. That is my goal. I understand my goal. Now I can start sorting out useful and useless information. So airplane travels at an altitude of, this is its starting height. Encounters turbulence that causes it to go up 400 and then fall 1,100. Okay, those are my useful pieces of information. Now I write a plan. My plan is 13,000 plus 400. Whatever I get, I'm going to subtract 1,100 from it. That's my plan. I now understood the goal. I filtered out the information that was useful. I made a plan to solve the problem. Now I will do the plan. I can't check that off until I've done it. So I add these together, 0, 0, 4, 3, 1. I subtract, I get 0, 0, 3, 2, 1. And this is my answer. I've now done the problem. Make the 2 look more like a 2. There we go. And now I reflect and I say, is there any way I could have done this better? Any way I could have done it more easily? And I think that adding some numbers together is not necessarily something I need to practice, and it might not be something that you need to practice. You might feel pretty comfortable about adding numbers, but maybe while we were going through this, you thought, this type of approach to solving problems is really good. Maybe I should practice when I come into a problem. I want to break it down into what is the goal, what's the useful information, let's make a plan, let's do the plan, and then let's see what we can, like, for reflecting is two parts. One is, did my answer make sense? Is it a reasonable answer? And the second part is, in doing this problem, is there anything I can take with me to make myself better able to solve problems in the future? Okay? And I think that for this one, that's what our reflection should be, is the idea that having a structured way to approach problems is helpful. Okay, let's do a few more of these. Looks like I have 6 of them. I've done 2. I'll do one more and then I'll move on. Which one looks the hardest? This one does. Only because it has the biggest paragraph, okay? I don't know if it's actually the hardest one or not, but let's do that. Getting some dinging on my computer. I'm going to find the dinging and make it go away. There we go. Okay. Okay. So, first off, I'm not going to read the whole paragraph first. I always want to know what the goal is first before I commit a lot of time reading a long paragraph. This is not a long paragraph, but, well, it's longer than the other paragraphs, right? But the first thing I see is here's a question. I can tell that because I saw the question mark at the end. What is the difference between the elevation of Beatty, Nevada, and Badwater Basin? Okay, so I have a goal. I want to find the difference between two elevations. Difference means subtract. Elevation is given by a number. My goal is to find out what two numbers do I need to subtract. Now, if I skim the paragraph, I see two numbers, and maybe those are the two numbers. So, I now have to start sifting through and finding out the relevant information. A family visited Badwater Basin in Death Valley, which is at an elevation of 282 feet below sea level. Below sea level. Its elevation is negative 282 because it's below sea level. Then they traveled to the closest city, which is Beatty, Nevada. Really? Closest city. My wife and I drove through Death Valley, and we came from Nevada, and I'm going to have to ask her if that was the city we drove through. I don't remember, but she would because she's smart, and I love her. Anyway, Beatty, Nevada has an elevation of 3,307 feet above sea level. Okay, so that's a positive number. And we want to find the difference in the elevations between these two things. So now I've understood the problem. We know the goal. We've found the relevant information. We noticed that this is a negative number, which was important. That's something that we could have skipped. Like, we could have forgotten that or missed that and then done the problem wrong. Now we're going to make a plan. I'm going to subtract that big number from that little number. So I get 3,307 minus negative 282. I go through the plan and say, hey, look, negatives are positive. So this is 3,307 plus 282. And then maybe I have to stack the numbers to do my addition algorithm at this point. 2 plus 7 is 9, 0 plus 8 is 8, 3 plus 2 is 5. Bring down to 3. 3, 3, 8, 9 feet above sea level. Now I reflect. Step 1 of reflection is to figure out, did I get a reasonable answer? There are several ways to check reasonability, but one way to do it is to round the numbers. I'm going to round this to 300. I'm going to round this to 3,000. This is negative 300. So I get 3,000 minus negative 300, but subtracting a negative is just adding. And I get 3,300. And I say, is that kind of close to what I got already? Say, well, kind of close. Maybe if I don't feel comfortable enough, maybe I round this instead of rounding to the most significant digit, meaning just round it to so it has one digit that's not 0 and the rest are zeros. Maybe I rounded this to hundreds. I'll round this to hundreds as well. This is now 3,300 minus negative 300. This gives me 3,600. I say, is this close to this? I say, that's pretty close. I feel that 3,600 and 3,589 is pretty close. So I feel pretty good about this. That's step 1 of my review. Step 2 of the review is to say, is there anything that I learned from this that I can take with me to future problems? The answer is probably this is a useful way of breaking down problems. Understanding, planning, doing, reflecting. Okay. I think that I feel pretty comfortable with my ability to read these word problems. Maybe you don't. Maybe that's your reflection says, I still feel scared of word problems. And maybe I need to practice those. Fortunately, we have practice in the homework. And if you run out of homework questions to practice on, you can get more off the internet. You can generate problems to solve. And if you run into one that you get stuck in that's hard, you can ask me about it and I'll be glad to help you with it. That was 3.4. Let's talk about 3.5. So 3.5 is about multiplying and dividing. Multiplying is repeated addition. We have 3 times 5. What that means is that we are going to add 3 5s together. We have a 5 plus a 5 plus a 5. Graphically, we can draw it the way that we did here. That gets us a 15. 3 times negative 5, well, that's going to be a similar idea. We're going to subtract 5, and again, and again. And that gets us, this is negative 15. If we are doing negative 3 times 5, then here's 0. We are going to, instead of adding 5, we are going to subtract 5, and we're going to do it 3 times. And that ends up with the negative 15 we have here. Notice that it doesn't matter if the negative sign is on the number that we are repeating or on the number of times we're repeating. It ends up with the same value either way. So 2 times negative 4, we have a 0. Here's minus 4. And here's minus 4 again. This gives us negative 8. We can fill out this chart. Anything times 0 is 0. Negative 1 times 5 is negative 5. And we notice as we're going down, the pattern is that every time this number goes down 1, this number goes down by 5. The next number is negative 10, and you can do the last one on your own. Same thing over here. We have 3 negative 5s. That gives us negative 15. 0 times anything is 0. As we let this number go down by 1, this number is going up by 5. So negative 1 times negative 5 becomes positive 5, because it is 5 more than the 0 we started with. A negative times a negative is a positive number. I think we might have to spend some time together on Tuesday talking about that. Rule is that when the signs are the same, you get positives. And when the signs are opposite, you're going to get negatives. So 2 times 3 is 6. Negative 2 times 3 is negative 6. 2 times negative 3 is negative 6. And negative 2 times negative 3 is positive 6. These ones are positive, where they have the same sign. These ones are negative, where they have opposite signs. So we'll do these. I'll do this one. Negative 1 times negative 2 is positive 2. Negative 3 times negative 4 is positive 12. And we still have a negative 5 here. 2 times 12 is 24. And we still have the negative 5 here. And now, if we want, we see we have positive times a negative, so we're going to end up with a negative number. And we might feel like we need to stack these and multiply them out. 5 times 4 is 20. 5 times 2 is 10, plus 2 is 12. This gets us 120. I'll do one up here as well. Let's do this one. We have a negative times a negative, so we'll end up with a positive. 5 times 9 is 45. So our answer is positive 45. you can do the rest of these on your own. And if you don't feel comfortable with these, check them on a calculator. But don't do them with a calculator. Do them by hand. Multiply them out by hand if you need to. But then check with a calculator afterward to make sure you did it right. Do we notice a pattern with the number of negatives? We should have. You need to do these problems and then write up what pattern you see. Here's some things to talk about. Ooh. We haven't defined exponents in this yet. So multiplication was repeated addition. We saw that up here. Let's see. 4 times 6 means 4 sixes added together. And we get 24. Exponents are repeated multiplication. So negative 3 squared means negative 3 times negative 3, which gives us positive 9. But negative 3 cubed equals negative 3 times negative 3 times negative 3, which gives us this part we already found out is 9 times negative 3. Negative times a positive is negative. 3 times 9 is 27. Our answer is negative 27. Fill out this table. We're going to take each of these numbers, these expressions here, and we're going to expand them into multiplication. So this is negative 4 times 4, for instance. And then we're going to give a result. 4 times 4 is 16, and we make it negative. Not so bad. Going this way, we have, let's do this one. We have 1, 2, 3, 4, 5, 6, 7. So we have negative 2 to the 7, which is the same as negative 2 to the 7, like this. We might have to talk about how parentheses work with exponents and negatives a little bit in class on Tuesday. But we have this, and we also have to give the result. Doing this by hand, we have 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, 64, 128. So this is negative 128. And you can fill out the rest of the table yourself. If you get stuck, please ask me in class on Tuesday. How many negatives are in this? That's kind of tricky because there are 2 there. But if we expand it, we get negative 3 times negative 3, and now we have 3 of them. Okay, so it says write the problem out as multiplication first before you answer. Okay, when it asks how many negatives there are in these questions here, what it means is write the exponent as a repeated multiplication problem first, then count the negative signs. So we have 3 negative signs here. Okay, whereas like in this one here, we have negative 1 times 1 times 1 times 1 times 1 times 1. How many negative signs? Just 1 negative. Negative. That's a T here. Sign. Okay. Just like addition, we are commutative and associative when we are talking about multiplication. Product means multiplication. So we can swap the order of A and B and get the same number. That is 2 times 3 equals 3 times 2. Or 10 times 7 equals 7 times 10. That 10 leaned over and turned into a 7. Okay, that's the commutative property. The associative property is that I can multiply from the left or from the right first, and I'll get the same number. So, for instance, I have negative 2 times 6 times 3. I can do the left two numbers first and get negative 12 times 3 is negative 36. Or I can multiply the right two numbers, the 6 and the 3 together to get 18, then multiply by negative 2 to get negative 36, and they're the same thing. Now, I don't know about you, but to me, this way feels easier. I guess it's because the last multiplication is a smaller number, and with this one, you multiply, well, I guess this is also a smaller number. I don't know. To me, it just feels like this way is a little bit easier than this one, but it's up to you. You might feel more comfortable multiplying by 18 than by 12. And that's just how it is. But often, like as you're doing the problems, you can spend a little bit of the brain power looking at it and saying, what's the easiest, most comfortable way for me to do this? And then try and do it that way. As long as you're picking a valid method, you might as well pick the easiest method that's valid that you think of, because you don't want to sit there thinking, is there a better way? Is there a better way? And never actually try anything. But if you see that there could be a couple of ways to do something, just think it out in your head a little bit. If I try this, is it going to work? If I try that, is it going to work? Does this way look better and that it's maybe easier for me to do? You want to do just a little bit of metagaming when you're doing your math problems, or really any problem, I guess. Let's look. Dividing integers. So if I have 35 divided by negative 7, this is the same as writing what times negative 7 equals 35. Well, I look and I say this is a negative and this is a positive. The only way to multiply a negative by something and get a positive is if you're multiplying it by a negative. So the number that we're looking for is negative. Does the quotient have to be positive or negative to keep the multiplication problem true? Yes. It must be negative. Quotient just means the answer in a division problem. So that's this number here. We just showed by rewriting as a multiplication problem that the question mark must be negative. Okay. Consider negative 35 divided by 7. Rewrite as a multiplication problem. Here it is. We get something times 7 equals negative 35. Now, this is negative. This is positive. The only way you get a positive number times something to equal negative is if the something was negative. Does the quotient have to be positive or negative? It has to be negative. I'll let you do the other one yourself. So, the signs are positive divided by negative has to be negative. Because when the signs are opposites, the quotient is negative. When the signs are the same, the quotient is positive. Just like multiplication. Positive. So I'll let you do this one, and this one yourself. And if you get stuck, then you can ask me. Okay. Let's see. Check your answers using multiplication. So, for instance, if I do this, I'm going to get negative 10. I check this by going 10, that's this number, times negative 10, that's this number, equals negative 100. And if I did it right, this number should be the numerator of the fraction. This one we get negative 2 is our answer, because a negative divided by a positive is negative, and 8 divided by 4 is 2. I check this by doing negative 2 times 4, and I get negative 8, which is the number I was dividing. I guess it's the dividend. Gosh, the terms for these things are so long ago when I was taught them. I don't remember them anymore. I just kind of do it. But anyway, same thing with the rest of these. Let's see. Let's do the last one because let's do this one because this one has 3-digit number in it. So we know that we have different signs, so our answer is going to be negative on this division problem. I'm going to do some long division. 3 doesn't go into 1. 3 goes into 16 5 times. 5 times 3 is 15. Subtract, I'm left with 1. Bring down the 2. 3 goes into 12 4 times. 4 times 3 is 12. I subtract, and I have no remainder. So our answer is negative 12. And then to check it, I do negative 3 times negative 12. The negatives cancel and give me a positive. 3 times... Why did I write 12? I wrote 12 because I was looking at that number. Should have been looking at this one. Hey, guess what? I just did the review step of Polya's problem-solving principles and found that my answer was unreasonable. Let me erase this too. And because of it, I caught an error. Negative 54. Okay, so negative times a negative is positive. That's good because I started with a positive. Now I check 54 times 3. 3 times 4 is 12. 3 times 5 is 15 plus 1 is 16. Hey, look. That's what I started with. So I must have done it right. Okay. So, just like subtraction, commutative and associative properties do not apply. 10 divided by negative 5 is negative 2. Negative 5 divided by 10 is negative 1/2. These are not the same number, so we cannot switch the order in your division problem and keep the same answer. Okay. Multiplication and addition work that way, though. Use the division properties of 0 to evaluate the following. The division properties of 0 are that 0 divided by anything, whatever you want to put here, 5, 52, 179, all equal 0. And the reason for this is division is just sharing. When you take something and divide, you're just sharing it. And so, like, if I have 5 candy bars and I get a group together and there are 5 of us and I say, let's share, each of us get 1. 5 divided by 5 is 1. Each get 1. If I have 10 candy bars and the 5 of us share it, 10 divided by 5 is 2. We each get 2 candy bars. However, if I have no candy bars and my group of friends, like all 5 of us decide to share the 0 candy bars, we all eat 0 candy bars. So 0 divided by 5 is 0, because if I have nothing, then when I share nothing, everyone gets nothing. That's perfectly reasonable. On the other hand, I cannot divide by 0. So there are a few ways to talk about this. We can rewrite this as a multiplication problem. Question mark times 0 equals negative 60. We say, well, what number times 0 equals negative 60? And you say, there isn't one. There isn't any number that does this. Because 0 times anything is 0, not 60. So anything times 0 is 0. So I can't get to 60 by multiplying by 0, so I can't divide by 60. On the other hand, I have 0 candy bars and I share it with the 32 students of my class. They all get 0 candy bars. This one is 0 because 0 is being divided by 9. On the other hand, this one here is, we're going to use DNE, saying this fraction doesn't exist. We can't divide by 0, so putting Negative 17 divided by 0 is not allowed in our math. It doesn't exist. It's not a number. Okay. Now we're going to do the same thing but with word problems. Same principles. We're going to try to understand the problem. We're going to plan. We're going to do the plan. Then we're going to reflect on the plan. So let's just do this one here. I have a question. So let's read that first. If 1 hour of aerobics burns 204 calories, how many hours did Cindy do aerobics this week? Okay. So 1 hour burns 204 calories. That means that we are either going to, 1 hour burns 204 calories. How many hours did Cindy do aerobics? So we're going to be given a total number of calories, and we're going to put it into groups of 204 to figure out how many hours there are. Each hour burns 104 calories. So if we group all the calories together into groups of 204, that's counting how many hours we have. Each group is 1 hour. Okay, so we understand the problem. We know we're doing a division problem. We found one of the relevant numbers. As we read through the problem, we find the other relevant number. So this number is going to be divided by this one. That's our plan. So we're going to get 204 goes into 612. Now that we have our plan, we're going to do the plan. 204 is less than 612, so it goes in at least once. 204 plus 204 is 408. So 2 times 204 is 408. We add another 204, we get 612. That's 3 times. And we say, oh, look, that is exactly the number we're looking for. If we tried to go any further, we would get 816, and that's too big. So we go in 3 times. 3 times 204 is 612. We subtract. We have no remainder. Our result is 3. She worked out for 3 hours this week. Might as well continue with the Death Valley theme. Joey's going on a hike in Death... Oh. I just broke our rules. Okay. Now, there's nothing wrong with reading. I'm just trying to stress this structure because, it's a good way to break down problems that are hard and difficult. If we practice it on the easy questions, then it'll be natural on the hard questions. And it'll help give us structure and help us get through the problem. So, first off, I see a question mark. So that means I'm going to read this part first, so that I know what my goal is before I dive into the paragraph. What is his elevation when he is done hiking? Okay, we're looking for a number. We're probably going to be given a starting value and then given a list of times that he goes up and down where we're going to add and subtract from that number. Okay, let's find all of the answers. Joe is going on a hike in Death Valley. He starts his hike at sea level, which is 0 feet. So that's useful. We know his starting value. Because of the heat of the hot day, he splits his hike up into 4 sections. It doesn't really matter how many sections he's divided it into unless they're giving us the values for each of the sections. So we'll look for that. In each section of the hike, he loses 55 feet in elevation. Okay, so yes, there are 4 sections, and he's going down 55 each time. What is his elevation when he's done hiking? So the expression is he starts at 0, and then he is going to, in 4 chunks, go down 55 feet, which we can immediately simplify to be negative 4 times 55. But this is how we'll do it. 4 times 55 is 220. And we have a negative times a positive, so we get this here. And this is not the bottom of the basin, but it's getting close to it. Anyway, we understood the problem. We made a plan right here. We even revised the plan to get a simpler plan once we saw some nice patterns for that, some nice simplifications. We did the plan, and is it reasonable? Well, he's losing about 50 feet 4 times. 4 times 50 is 200. This is a little more than that. Yeah, this seems reasonable. So, not too bad. Get through 3.7. So, we're going to simplify expressions containing integers using the order of operations. So, we have this here. We know that parentheses come first, but there aren't any. Exponents come next, but there aren't any. Multiplication and division comes next. We see division here, so that's the next thing we're going to do. 20 minus 8. There's no more multiplication or division. We go to the last step, addition, subtraction. There is subtraction. We subtract, we get 12, which is what it says in the correct way. On the other hand, if you reverse the order and subtract first, you get 4, which means that you evaluate 2, which is wrong. If we wanted to do the subtraction first, we would write it this way, 20 minus 16 in parentheses to say that that goes first, then divide by 2. This makes you do the subtraction first because parentheses come first. You can really think of parentheses, instead of thinking of them as like the starting value of the ordering, the start of the order of operations, you want to think of it more as this is a way to reverse the order of operations. If I want to do subtraction first, I use parentheses to make that happen. Because sometimes we do want to subtract first. But when we are writing mathematics, we want to have the way we write it, we want it to mean only one thing. And so we make some decisions, and we all agree to follow the rules so that the math can be clear and always mean the same thing every time. Okay? We've just agreed that multiplication and division come before addition and subtraction, and that we use parentheses to reverse that order whenever we need to do the addition or subtraction earlier. Okay, let's go on. The order in which mathematical values are combined is the same in every language. That just means that, like, we might not call them parentheses. We'll use whatever it's called in whatever language we're in. But we always follow this order, even if the names of the symbols are different in a different language. Okay. Consider each sentence. Does it matter how I write them? Mitt Romney said Barack Obama won the election. In this situation, Barack wins. In this one, where all we did was move the punctuation, now it's Barack Obama saying that Mitt Romney won the election. So, the way that you write things, the parentheses and the exponents and all of that, is kind of like these grammatical symbols, that placing them in different places changes the meaning. We have to be careful. That's why we all have to agree on what the symbols mean. Okay, so we have a bunch of things where we're going to use the order of operations to evaluate some stuff. I'm going to do this one because it looks fairly complicated. So, looking in here, first thing I do is I look inside my sets of parentheses. There's nothing to do inside of that set of parentheses, but that set of parentheses is the most inside set, right? So like I have these outside parentheses, and then I have inside parentheses, and then I have more inside parentheses. I start from the inside and work out. There's nothing to do there. It's just a -5, but now I'm going to multiply it by -3, so I get -25 plus, here's my grouping symbol, here's my next grouping symbol, 16. I'm doing this first because I check this parenthesis, there's nothing in it, so I go out to the next set of parentheses, which is this one. And I see that there's a multiplication and a subtraction, so multiplication comes first. -3 times -5 is +15. Okay. I see this is my next inside-most set of parentheses, so I do that next. 16 plus 15 is 31. The tops and bottoms of fractions always count as if they have parentheses around them. So the next thing I need to do is up here, this -12 minus 3. Now the next thing to do is this division. Fractions are division. I do -15 divided by 5. -15 divided by 5, the signs are different, so I get a negative number. 15 divided by 5 is 3, so I get -3. Now the next thing in parentheses is the subtracting 3. I get 25 plus 28, which gives me 3 as my final answer. Okay. Remember Polya's problem-solving strategies. So let's look at these. Looks like this one might be the longest problem, so let's do this one right now. We have a question and we have a command. So let's read both of these. If they lost the same number of yards each time, what was their yardage per play? So each time makes us think division because we're taking something and splitting it up into each time. We're splitting up into groups that are the same size. And we're going to express our answer as an integer. So we can do that. Let's read the problem now to get our data. In a recent football game, the winning team had run the ball 3 times. So that's each time. There are 3 each times for a total loss of 15 yards. So we are taking the 15 yards they lost and we're dividing it across 3 downs. I know it doesn't say down in there, but a try is a down in American football. So there's our expression, and then we have to evaluate it. 3 goes into 15 5 times. When your signs are different, your answer is negative for division. So we have this many yards per down, and this is -5 yards per down. Okay. Let's do another one. Let's do this bank account one. Joe opened a brand new bank account that had a $0 balance before he had a chance to deposit money. 5 charges of $65 each hit the account. Okay. So since they are charges, these are negatives. There are 5 charges of -65. This is our balance. When we multiply this out, we get 325. I guess usually we would put the negative sign in front of the dollar sign. So I guess the dollar sign goes there too. Okay. Not bad. Do some pattern recognition. I think that this one looks like the most complicated pattern. I am cutting something in half. I cut it in half again. The next number is cutting in half again. This one here, I'm multiplying by 4. I'm multiplying by 4. And then I multiply by 4 again. 4 times 8 is 32. 4 times 4 is 16, plus 3 is 19. Negative 192. Okay. More Polya problem-solving strategies. Here we're just going to focus on the first principle of understanding the problem. Okay, so let's look at the question marks. What is the difference in temperature between Miami and New York? What pieces of information are relevant to solving the problem, which are not? So this here is actually the problem statement. We want to go through this problem and figure out what information is useful, what information is not useful. The goal is to find the difference in temperature, so we're only caring about the temperatures. Let's read the statement. The temperature in Miami, founded in 1896, which is not useful, we don't need to know when it's founded, was 63 Fahrenheit. The temperature in New York City, founded in 1664, again, not needed, was -6. What is the difference in temperature? So the pieces of information are Miami is 63 degrees Fahrenheit, and Florida was -6 degrees Fahrenheit. These are important. And then not important are, well, founding dates. We don't need to know when the cities were founded if the question is about the temperature. That's all you have to do for that question. Again, what pieces of information are relevant to solving the problem? The problem is, how many feet did the geologist have to drill? So we go through this statement, we find what's relevant to how far they had to drill. Being able to sort through what's useful and not is extremely important. Okay. Use Polya's second principle to devise a problem-solving plan. So, Kelly had $45 in her bank account. Oh, we should probably still use the understanding thing first. Write an expression for the solution, being sure to indicate the correct option, or correct operation. We're trying to figure out what the balance is. So we start at 45. She went to 2 different stores and spent 15 and spent 40. What's her new balance? This is what we are asked to do. We're just setting up the problem. This is the plan. And that's it. Let's do this one. Write an expression for the solution. Indicate the correct operation. So, the next day, what is her balance? Isabel has this much in her account. She wrote checks for this amount. Checks are money that goes out of the account, so we were subtracting. She deposited a payroll check for $638. That's positive because she's being paid it. The next day, $650 was deducted for month. What is her account balance now? Just writing the expression. This is the expression. That's all we had to do. Okay, now we're skipping to the fourth principle because the third principle is doing the plan, and the rest of the homework is doing the plan. It's all of the math that we've been doing up till now. So, like, this was the doing. This is the doing. So we don't need to have that in our Polya section because that's the rest of the homework. Okay. So, fourth principle is review. We do principle 1 is understanding. Principle 2 is making a plan. Principle 3 is doing the plan, which is all of the calculation you've been doing up till now. don't need to add a special section for that here. 4 is reviewing information. Okay, so it says a student came up with an answer of -10. Is the student correct? Why or why not? Let's see what the question is. What was the average temperature Monday through Friday? Note average is found by adding up all the numbers, then dividing. So we need to see, they said -10 was the average. Average is by adding up the numbers, then dividing. So let's add up the numbers. We have 12, 5, -6, -14, and -7. These are the things we're adding up. So this becomes 17. This becomes -20. That's a -7. This becomes -3. And there's still the -7. And we get -10. This is the total. It says an average is found by adding up all the numbers. That's finding the total, then dividing by how many there are. So this is the total here. The average is you take the total and you divide by how many numbers you started with. -10 divided by 5 is -2. This is the average. So, is the student correct? No. Why? They gave the total, not the average. Okay. There's a gopher problem. There's a chemistry problem. There's this one here. Let's do this. We'll find the error in the student's work. I know I told you to look for questions and commands. And then I just started from the beginning of the paragraph, but find is a command. It's telling you to find an error. So we want to find the error, and we want to know what type of error they made. What is their misunderstanding in the order of operations means explain what the error is. So the question is to evaluate that. We look and we see, well, the first thing they did was they copied the problem. And it looks like they copied it correctly. The next thing they did was they squared the 4, and that looks good. The next thing they did was they combined the 16 and the -3 to get -19. So this is the error. And the error is they subtracted before multiplying. What they should have done next is multiply the -3 and the -4. So this should have gotten on -16 plus 12 plus 5. And then that should give them -4 plus 5, which is 1. There's the correct answer. Not that we were asked to find it. We were only asked to find the error and tell what kind of error it was. I'll let you do this one on your own. Now we'll do the full polio problem to a question. We can do the card game one, or we can do the day trip one, or we can do borrowing money from a cousin, or we can do playing on a game show. Let's do the game show because that's the last one, and usually they get harder as you go. So I'm going to do this one with you. A game show contestant receives $50 for every correct answer and pays $45 every. We should really read the questions first. How much money did he end up with at the end of the game? So identify and organize key information in the problem. This is the understanding step. This is the planning step. This is the doing step. And this is the reflection step. Okay? So identify and organize key information. Is there any irrelevant information? The goal is to find out how much money they go home with. So as we read this, we say a game show contestant gets $50 for correct answers. That's money they go home with. That's important to know. And pays $45 when they get an answer wrong. So those are both useful because the money that they go home with depends on how much money they're paid and how much money they lose. After a game of 30 questions, the number of questions is important because they're paid based on the number of questions they get right and wrong. They miss 16. So how much money do they end up with at the end of the game? Okay, so we know that there are 30 questions total. We know that's 50 for every correct answer. 45. We're going to put negative 45 for every incorrect answer. There are 16 answers wrong. If we subtract this, we get 14 answers right. Technically, that's skipping ahead to doing some extra problem. We're planning and executing part of the plan by finding that, but that's okay. Anyway, this should give us all the information we need to solve how much money he gets. Write an expression for the solution. Be sure to indicate the correct operations. Well, first off, we needed to do the 30 minus 16. You get 14 right answers. That's one thing we had to do. The next thing is we get 50 times the number of correct answers minus 45 times the number of incorrect answers. So this gets us the total money he earned, and this gets us the total money he lost. And subtracting them tells us how much money he actually took home. Now we have to do the problem. 50 times 14 minus 45 times 16. Here's 50 times 14. 5 times 4 is 20. 5 times 1 is 5, plus 2 is 7. 6 times 5 is 30. 6 times 4 is 24, plus 3 is 27. Anything times 1 is itself. We have the 0 placeholders there. 0, 7 plus 5 is 12. 1 plus 2 plus 4 is 7. So we get $700 that they earned. This is the 700. And this is the minus 720 that was lost. And that means that they lose $20. Reflecting on the answer, does it make sense given the context? Well, there are a few ways we can do this. So we see that they missed more questions than they won. We see that even though you gain a little bit more money for winning a question than you lose for missing a question, you do see that they're fairly close. So I mean, we could do the rounding thing to check. We could round everything, but we could also say that if we just let the right answers cancel the wrong answers, then the 14 right answers and the 16 wrong answers cancel to leave 2 wrong answers. And since the questions are worth about the same, it's about $90 that he should have lost, which is a bit high, but also the payouts aren't exactly the same either. So they don't perfectly cancel. But having something that's, less than $100 and fairly close to 0, it feels about the right for the answer. Okay. I think that I will let you work through the rest of these problems yourself. I hope that they go well for you, and I will see you all on Tuesday. If you have any questions, please let me know. And good luck. Good luck for the rest of the semester.